In this video, we are going to focus on derivatives of exponential functions. You will find this on page 479 in the Namibian AS-Level Mathematics textbook Y equals mx plus c to success. Derivatives of exponential functions. Differentiating the function fx equals e to the power of x. In chapter 9, we learned about the special number e. We are now going to find the derivative of this function. The power rule will not work as it requires the index to be a constant and the base to be a variable. That is exactly the opposite of what we have with this function. Let's explain it by differentiating from first principles. It's just for explanation's sake. So take a point, okay, this is the general curve. On the curve, fx and the point b that is close to a point. So this is going to be the function and that is going to be the function plus h. I will now bring that in. Okay, there is the function. This is x and that is that little bit of distance h. Okay, so the coordinates of this, where h is a small increase in the value of x and this is the corresponding small increase in the value of y. So this is the x value and if this is then the y value. Okay, now according to the graph, the coordinates of b are, and I want to write it in because now it will make more sense if I write this is x, but the graph, so this one will be ex and this one will be, okay, let's just write it, ex plus h. Okay, so this is my y values now. This is my x values. So the gradient of the chord, so this is my coordinate point, x, ex, x plus h, ex plus h. So the gradient of the chord, this is the difference in y. So it's the difference in this values. Okay, there I just wrote it as the graph, but then it's this minus this, and then the difference in x, this minus this. But if I look at it, I will see that this will cancel out. There's the h, and I'm left with this. But if, and I want to make it a little bit bigger, that you see better. Okay, so I'm going to take out a common factor. But if I take it out, so just break this up in this, so that I take this out as a common factor. Okay, so then this will be left. Okay, this one minus 1, this. Okay, so it's a constant. There's no h, so just remember that's a constant. The table below consists, now say for example, I'm taking now this values. I want to show you. And I'm approaching 0 with that values. So let's take very 0.1 and then we make it smaller. So we're really trying to go to 0 from the positive side and we're going to try to go to 0 from the negative side. So if I substitute it then in here in the place of h, remember e is 2,7, it's a constant. If I substitute, I'm getting these values. Do you see? But look at the values. It's 1.05, 1.00, 1.001. It's striving to 1. The same from the negative side, it's striving to 1. And that's why I'm saying, just right. From the table, we can see that h is tending to 0 from either the positive or the negative side. The solution tends to 1. Therefore, this answer, they are actually just saying that will become 1. And anything that you multiply, so if you have e to the power of x and you times it with 1, you just get e to the power of x. Okay, and that is why then this, if you differentiate it, then it will just be e to the power of x. And here comes the rules. It's not necessary that in this syllabus that you know from first principles. It's just to understand it better. So the derivative of the exponential function is exactly staying the same. The derivative is the same as the original function. Okay, but if, and let's just move on. If I'm going to put something extra with the exponent, what do I do then? Now, and I want to show you this because this is easy. This is just using the chain rule. I just want to make it bigger. Okay, so this function, so let's make e, and then we make actually this, we make u. Do you see? And that's why. And then you have u is equal to this. So if we differentiate, this stays the same like the previous one. If we differentiate this, remember we differentiate to x. So it's just a, that's a constant, it becomes 0. And if we multiply the chain rule, then it's just this, and we just replace in the place of u, ax plus b. So basically, if we look at it, here is the rule. It's just the value in front of x that we multiply there with in front. So in the exponent, the value in front of x, the constant, we multiply it just there in front of the e. Okay, so let's look at a few examples. Differentiate with respect to x. So if I differentiate, so this is just a 4, so I'm just going to say it's that, what is the value in front of x in the exponent? 4. So it's 4, and I just rewrite. Did you see? This is exactly the same as it stood there. So I just rewrite that function, and that's the answer. If it's negative 12, what is the value in front of x in the exponent? Negative 3. So I multiply with that negative 3 there, and just rewrite that one, and that's a negative times a negative is a positive. What's the value in front of x? A 5. So I just multiply with the 5, and I just rewrite that. It's not difficult, the rule. I want you to stop the video, and I want you to do all of them. It's not very difficult, but it's just a new rule, and it's a little bit a different approach in this rule. Okay, so you can continue the video as soon as you are finished. Just going to make it a bit smaller again. Okay. So if I'm going to start with that one, that will be now number 10. So I'm just going to, because it's written like this, I'm going to do it like this. Let's just look at my way. I'm actually doing it the same as there. It's very good to get used to different notations and to be able to work in different notations. So because there's not a y equals, so I use this notation then. So, and then I just write the function down. Now remember, this is exactly, and I want to show you, this is exactly just, if this, I just rewrite this, okay? So this will just e to the power of x. There's just a 1 in front, so if you multiply with 1, it stays 1, okay? Number b. This is d over dx, and this is negative 2e negative 4x. And this will give me a value of, now don't forget, you're going to take, I want to make it red, the value in front, so first write that negative 4. And then just rewrite the function. And that will give me a value of 8e negative 4. Okay, and then it's number C. Oh, I want to use another color. Again, I use this notation because there's not a y, and so this is a nice notation then to use. Okay, it's just a bit small. I hope you could have seen. So it was x over 2. Okay, but again, what is the value in front of x? There's a 1. I want to make it red. There's a 1 and there's a 2. So the value in front of x was a half. Do you see? There's actually standing, and I'm going to write it here, a half x. That's the value in front of x. Okay. I didn't write it very good here. I will prefer to just leave it as it was. X over 2. So what was it, the value? It's a half. And then just rewrite the function. So 6e x over 2 close, and that will give me an answer of 3e e x over 2, final. Okay, and then the next one, what will I do now? Green, d. I start again nice, so d over dx, it means differentiate. So it's e, it's 3 minus 5x. Okay, now again, what is the value in front of? Grab that sign, it's negative 5. So don't forget, I will say negative 5 e 3 minus 5x. And what will be my final answer? Negative 5 e 3 minus 5x. And that is my final answer. And that's how you do the basic ones.